Good morning everyone. So today we are going to cover the last topic of Legendre polynomial, which is Legendre series. So let f of x be a function defined from -1 to 1. Then the Legendre expansion of f of x is written as summation cn pn x, where, so this is not dx, where cn are the constants. It means that any function which is defined from -1 to 1 can be expressed as a linear combination of Legendre polynomials. But the question comes that how do we compute cn here? Spend some time and try to think, can you use orthogonality? So your f of x is something like this: c naught p naught plus c1 p1 plus so on, and cn pn plus so on. Let's say n is fixed. Yes. So what you do is that you multiply both the sides with p and x and integrate from -1 to 1. So the first term would be p naught pn dx and so on, and nth term would be pn square dx and so on if n is fixed. For example, n is 5, then you will have c5 p5 square. Now using orthogonality, all the terms m is not equal to n is 0 except pn square, and I know that pn square is 2 by 2n plus 1. It means that for all n, cn is 2n plus 1 by 2 minus 1 to 1 f of x pn x dx. So very easy concept. Yes, so in MCQ you can expect the question where you have given a function and they can ask you some value of some coefficient, for example C3, C4 or so on. So for an example, consider that f of x is given as follows: 0 from -1 to 0 and 1 from 0 to 1. You need to find its Legendre series. So Legendre series is f of x is equal to summation cn pn x, where cn is obtained. We have already discussed it. Now f of x is defined from 0 to 1 only, and it is 1, so it would be 0 to 1 pn x dx. Now the problem here is that you don't have the values of p and x. When you want to write down the Legendre series, you should write first few terms, 3-4 terms: c naught p naught plus c1 p1 plus c2 p2 plus c3 p3 and so on. In that case, you need to compute c naught, c1, c2, c3, and for that you need p naught, p1, p2, p3. So how do you compute p naught, p1, p2, p3? There could be many ways, but the simplest approach is you should use Rodriguez formula. So using Rodriguez formula, try it by yourself and you will get the following values: p naught is 1, p1 is x, p2 is 3x square minus 1 by 2, p3 is 5x cube minus 3x by 2. Yes, these are sufficient. So now if you try to compute c naught, for example, c naught would be half 0 to 1 p naught x dx. It comes out to be half. Other integrations are quite easy. Please do verify by yourself. So once you have few values, then you can write f of x to be c naught p naught plus c1 p1, c2 is 0, so c3 p3 and so on. So that's all from today's class. Thank you very much.